Good morning, everybody. Today I'm going to go over the PowerPoint on weathering, which is found on page 125 to 128 in your note packet. Okay, the different types of weathering here. Now, weathering has that word weather in it, so they both kind of go hand in hand, right? The weather outside is going to affect the weathering of the rocks. So what exactly is weathering? Weathering is simply just the breakdown of rocks. We're taking large rocks, the bedrock, and we're turning them into sediment. And we know sediment will eventually turn into sedimentary rocks at a later time. All right. Now, sediment, some examples, and we can find the examples on page 6 in the reference table, are sand, silt, clay. You also got boulders, cobbles, and pebbles as well. Now, there's two types of weathering. We got mechanical, also known as physical weathering, and chemical weathering. The main difference between them is that mechanical weathering only changes the size, shape, and texture of the rock. Whereas with chemical weathering, there's going to be some type of chemical reaction that changes the actual composition of the rock. Now, we've seen both in class with demos I have done. See if you can think of what we've done in class that regards chemical or mechanical weathering. If you were thinking for chemical weathering, we put the acid on the limestone, right? And we watched the limestone fizz with the acid. We were changing the actual composition of the limestone. It was a chemical reaction. And with mechanical weathering, if you were thinking we were testing a mineral's cleavage, you're right? We broke the mineral with the hammer. It broke into many different pieces, but at the end of the day, there was no chemical reaction. The mineral just got smaller and turned into different shapes. So now what we're going to do is go over each type of mechanical chemical weathering. The first type, very common here in New York, and is an example of physical weathering, is known as frost action. Frost action occurs because when you freeze water, it expands, and when it expands, it turns, basically pushes the rock particles apart, and the rocks break up. Now you can see here we got a picture of just a road, and what we're looking at here are potholes. Potholes are an example of frost action, and here in New York, it's a major issue where we spend millions of dollars fixing them up in the springtime, and you can see crews out there putting new asphalt down, trying to cover the potholes. But it's basically because water expands when it's frozen. Okay, frost action can only happen in a cold, wet climate. You need alternating temperatures. You need the temperatures to go above freezing, and then you also need the temperatures to be below freezing. And you need it to alternate night and day, where we can refill the crack with water, and it pushes those rocks a little further apart until the hole or the rocks break up. The second example of physical weathering here is wind abrasion. Okay, now wind abrasion is only going to happen in a hot, dry climate, because we know when sand gets wet, it's too heavy to lift off the ground. Okay, wind abrasion is a very slow process, right? And we've actually used wind abrasion. Mechanics use it if they want to strip the paint off a car. It's called sandblasting. Okay, and basically they shoot high particle sands at a high velocity at the car, and that will take the paint off. Here we're looking at a window that was created by wind abrasion right in the middle of that bedrock, and that's because the rock in this area was less resistant to weathering. Must have had a softer hardness, those minerals, and allowed the wind to really eat apart at that specific location. The next example is an example of chemical weathering. This is the carbonation of limestone. Okay. Basically, the carbonation of limestone is how we're going to have caves forming in and around the United States. Okay. Caves form in limestone because limestones react with acid. Limestone contains the mineral calcite. Okay. This is mostly going to happen in a hot, moist climate. The great example where you have a lot of combination of limestone is Florida. Florida, almost the entire state is built on a limestone bedrock, and it's hot and moist down there. Florida does have a major issue with what we know as sinkholes. A sinkhole happens when the roof of a cave under the ground gives way to the overlying weight, and then everything else almost funnels in like an hourglass if you were flipping that upside down. The next example, root action. And we've all seen this. Growing up, I was a skateboarder, roller hockey player, and I'd ride up and down my block, and numerous times I've tripped over sidewalks that have been lifted up by the roots of a tree. And once you take a tree and it lifts up the sidewalk, it's much easier to crack the sidewalk because the weight is not distributed evenly. And all we're doing is cracking the sidewalk. So that is an example of physical weathering. Our next example of physical weathering is stream abrasion. Now, abrasion is a general term where we're saying that rocks and sediment scratch and bump into each other. So that's just a general statement, right? We could have a abrasion when rocks are tumbling down the side of a hill. In this scenario, we're referring to it happening in a stream. Okay. Whenever there's stream abrasion, we're looking for rounded sediments. Okay, that is a key there, that those rocks have been weathered by stream abrasion rather than some other types of abrasion. And this is going to occur mostly in rivers and streams, and you need a moderate climate. Notice with each different type of weathering, we're looking at different climates that they can occur. Okay, and then the last one is exfoliation. It's an example, a little less common. I don't really see it that often on the regions, where when rocks are heated and cooled, they expand, contract, expand, and contract. When you heat something, it expands. When you cool something, it contracts. And after a long period of time, that expanding contraction breaks apart the bonds in the rock, and then they tend to easily break apart and come off the side of a mountain. Okay, for that, you need some type of moderate climate, right? You need alternating temperatures where it's going to be warm during the day, cold at night, and this continuously of expanding and contracting. Sometimes certain sides of a mountain will have more exfoliation than another. If the side is facing the sun, it's going to get heated more. If the side is not facing the sun, it doesn't get heated as much. So exfoliation a little less common with the other, compared to the other forms of weathering. All right. So that's your PowerPoint. And from here, we're going to go to the factors that affect weathering next. Again, if you have any questions, feel free to to email or message me on Teams, and enjoy the rest of the day.